Question number 26. It reads, a flat air capacitor C consists of two large plates that are close to each other. Initially, one of the plates was uncharged or not charged, while the other had a charge Q. If the entire space between the plates is filled with a slab of finite electric resistance, estimate total amount of energy lost in the slab. So if we draw the picture, it could be like this. This is the two parallel plates and one is charged by Q, another plate has a zero charge. Then we know there is going to be charge redistribution. After charge redistribution, you'll find the outer plate will be having plus Q by 2, inner face will have a plus Q by 2, its opposite is going to have minus Q by 2, and this will have a plus Q by 2. So this charge redistribution you must be knowing from your basic concepts. So equal and opposite charge appears on the facing faces, that's point, and that makes it capacitor. And moreover, outside charges are identical. So you'll find this is going to be charge capacitor. Then after what you are doing, you are filling with some slab so that it is creating resistance. So there is a potential difference and there is a resistance inside, there's going to be current, so heat will be lost. And that heat is going to be losing or losing the energy. So what is going to be basically ultimately or eventually, that whatever the energy stored by this capacitor is, that will be lost in form of heat via the resistance. So in order to find how much amount of heat is being lost, that means we can find out how much the energy was stored in this capacitor. The entire energy has to loss. So stored energy in the capacitor is equal to the amount of energy or heat loss due to electric resistance. And which stored energy we need to find, which was initially, and it is decaying to zero. Now this capacitor is a capacitor having charge Q by 2. These outer charges are not going to play any role, they are not going to create any electric field in totality, because the field of this face and this face, they will cancel out each other. So in the space you will find no electric field will be present. Electric field is only within the capacitor. So energy in the capacitor is inside the capacitor itself. So it's going to be like Q square upon 2C, where Q is going to be Q by 2. So charge square upon 2C is the expression. So that's energy loss. Now we can simplify, it's going to be like Q square and then it's going to be 8C. Q square by 8C will become answer. That is second option is the correct answer. Thank you.